By the way, MoveKit, best starter.
Agreed.
Very good.
Agreed. It's objective.
Okay. Okay. Hi everyone. I'm Nicolas Ahn. I'm a third-year computer science major with a minor in data science, and today I'll be presenting about microservices. This will be just a gentle introduction, and yeah. So before I go into microservices, I wanted to talk a bit about what monolithic architecture is. So monolithic architecture is basically just the traditional software development architecture that we probably all use for classes or coding assignments or side projects, which basically is when you have a single project where all the functionalities are in that same project, right? And well, the word monolithic literally is a single large block. So from the analogy, monolithic architecture is when a project, all its functions are in a single large block, or folder. So as a demonstration, let's say we have an application, an e-commerce application, right? Where we probably, inside the application project, we probably have a UI layer that, does all the front end stuff, and then we have the backend layer on the bottom where we probably have like an authentication algorithm or like a card feature, payment, recommendations, and report, and stuff like that. So everything like this is how we would usually structure a monolithic architecture. Everything would be in just one application. And there's a lot of benefits from it, because not only we're used to this type of architecture, but it is very easy to develop. It is very easy to deploy and easy to manage, since everything is just coupled in a single project. But the simplicity also comes with a few cons with it, where first, it is language and framework dependent. So meaning that if, for example, let's say you write your front end in React, if you want to add more things to your front end, you'll probably be in React. You cannot really, add new technologies or new components with different structures outside from what you originally had. Another thing is that growth and scaling can be a bit of a problem, because as the scope of your project becomes bigger and bigger, so does the complexity of it, right? So it gets harder to read, and if you're not managing and modularizing your code very well, things can get messy. If you try to add more new features, if you don't really know what's going on or what things are affecting others, you can start creating spaghetti code, and it's not very good. It also has a scaling issue where, for very large projects, it can take longer to run as the project gets bigger. And also another thing that it is a con is that updates, rather than it be like a very big update or a single line of code, you probably have to redeploy the whole entire application, since it's only one application. And finally, errors. Like if you have a single error, that can cause the whole program to crash and nothing works. So that's not very good. And that's where microservices come in handy. So what are microservices? So microservices is a development architecture just like monolithic, but the difference is that you break down that same application into different, smaller, independent services. That's why it's called microservices, right? They all run at the same time, concurrently, and they can communicate with each other through HTTP requests and RESTful APIs that we mentioned before. And just as an example, let's have the same e-commerce application that we had in the previous example. But instead of making it a monolithic architecture, let's try to break it down into microservices. So, okay, the application, as you remember, the backend had different features, such as authentication, card, payment. But instead of being part of the application, let's separate them in their own different programs. And they will all run together, right? And since they're all running together, the way that they're gonna communicate with each other and use each other's functions will be through RESTful APIs that you will probably write yourself, right? And yeah, some of the benefits for this is that it has an easier process adoption, which means that if you need to add a new feature and it makes sense to create a different service, you can just add a new service, connect with the RESTful APIs, and that's it. Another thing is that since those services are running separately from each other, they can have their own language of choice or different structure. For example, you could write your cart service in Java, or if you write the authentication, you could write it in Go. So it's very flexible like this, and you usually depend on not only that's very useful if a certain language is better for a certain kind of service, or if the coders that are working in a single project are more familiar with one language than the other. You can just combine different languages together. And yeah, another benefit is that it has a greater maintainability. So since everything is coupled in different services, things are modularized in smaller pieces, so it's easier to manage, organize, keep track of things. And actually, in the workforce, very large companies with very large applications will divide their own coding team into different teams that works in very specific microservices, so that they should only focus on the services they're working on and services that relate to their own microservice, right? They don't really need to know the whole structure of the application. So imagine if there's an application with like 100 different microservices, right? You don't really need to know how all of the 100 different microservices work. You just gotta focus on the microservices you're working with. And another good thing about separating each thing is that each of the services have independent scaling. They can scale, by adding features to a specific thing, or they also have z-axis and x-axis scaling and stuff like that. And last is that it has less risk in change. So if there's a change in code, an update in, for example, just the cart service, you just got to redeploy the cart service. You don't need to redeploy the whole application. Another thing is that if one of the applications stops working, it doesn't affect the other applications. So for example, we have the same e-commerce application, and let's say the authentication service crashes and burns, right? All that happens is that the other microservices will not be able to do REST API calls to authentication, but the rest of the application is still working. So you can probably still look through the catalog of items, go to your cart, make payments as a guest, stuff like that, but you won't be able to log into your own account. But the website's still working, so that's not as bad of a failure. And if you need more reasons to learn it, here are some stats. According to some research, 85% of respondents from large companies, they're currently using microservices, and 14% are planning to transition to them, actually. And some notorious examples are Netflix, Amazon, Spotify, Twitter, eBay, Uber, and the list goes on. So if you're interested in full stack, front end, or back end, this could be something you could look into if you want to work with this. So how would you build your microservices, right? So a lot of popular languages, are very good to make microservices. The most popular ones include Java using Spring Framework, Python. There's a lot of different web frameworks that you could use, such as Flask, FastAPI, or even Django. Go, it's a very good one, actually. I recently learned it, and basically is as simple to write as Python, but has the same performance, if not better, as Java. So it was very fun to learn. And also the good old Node.js. And right now I'm going to do a demo with 3 different services, right? One would be the authorization service, which will do the login stuff. And then after logging in, you send the information to the authentication service that I wrote in Go, which will check through a database if if the credentials are correct, and if it's right, we'll go back to authorization, and then The authorization service will, allow the user to go to the music catalog service that I also wrote in Python and Flask. So let me just pull up the project real quick.
Is it indexing?
Sure, we can do this. Okay, so this is the first service. I'm just gonna run this real quick. All right, so one of the services are running, and this is the authentication service that I wrote with Go, and using Fiber, which is one of the libraries that they have for web frameworks, and it's running as you can see now. And finally, this is the the music catalog This is the music catalog service that I'm actually using Spotify API to get some musics. So yeah, that's very cool. And now if I open the link, 1 second. I forgot the link. So I'm hosting them locally, by the way.
What's the port number?
So since there are different services running concurrently, they're in different ports. So one is in port 8082, 8081, and 5000. Okay. All right, let's see. Okay. So this is the so from the services here, this will be the authorization service page where you add your ID and then the password, and then you just log in. And what happens is that you checked with the authentication service and to see if the credentials were right, and they were right. So it redirected me to the music catalog service. And now that I have it, I can start. And yeah, I can get my music. Big Georgie fan, by the way. But as you can see, all these different services are running together, and they're communicating by doing HTTP requests. And that's how we can host different services in different ports and still communicate with each other. And that's how a microservice structure would be. So we can turn on the lights. Thank you. And yeah, so just some final comments. This is just the tip of the iceberg about microservices. They are very, there's a lot to learn about them. So if you want to look more into it, just get the language of your choice, try to look at some guides, documentation, stuff like that. You can also look into like how to connect databases or how companies use different management tools like Kubernetes or Docker to manage all the microservices. There's a lot to explore. Second thing, monolithics is not bad. I'm just saying that monolithic is still used widely across the industry, and we'll keep using this for classes and stuff like that. I was just introducing this microservice architecture as a use case. And third point, don't turn everything to microservices, right? Again, it's a use case. You probably only turn things to microservices is first, makes sense to couple things into different modules. And second, for very large applications. If you have a very small application, you probably don't need to microservice that. And finally, plan before doing microservices, right? Because microservices can be very complex. So if you're just blindly going to make microservices and you can start creating services that don't really make sense. And in a work environment perspective, that would cost you money for the company and resources and stuff like that. So yeah, that concludes my presentation. So any questions?
I imagine that having like tons of too many microservices can be bad for like speed, since the communication between microservices takes time, right?
Well, if you're only doing one call to like a single microservices, shouldn't affect the communication that much unless you're doing like different calls at the same time to synchronously.
Okay.
That might affect, but if it's a single call, it shouldn't affect.
Gotcha.
Can you talk more about the Spotify API I was able to get the song from your
Alright, so the Spotify API, actually, if you they have their own page with like showing their web services, and they have very good documentation. Want to check it out? So if you go to just search on Google Web API, you can look into docs and stuff like that. The tricky part is probably going through their authentication, because Spotify has this authentication layer before you can use the API, and it can be a bit tricky for you to pass that if you don't have a lot of experience on it. But again, Spotify has very good documentation, just follow that. And these have a lot of different features that you can use, like accessing your data, like the music that you listen to. You can also have access features like play music, search for music. So in the Discover page of the API, there's a lot of different examples of websites and web apps using the Spotify API. Yeah, it's very neat. You can make your own music player, you can create a music recommendation page using the Spotify recommendation algorithm, and all through the Spotify API. So
So you made some microservices in Python and Go. Which of those two do you find easier to work with as it relates to making microservices?
for easier, they're very similar in the sense of how hard it is to code. But I would say Python would be slightly easier just because I feel like working with JSON thing. Because when you do RESTful APIs and HTTP requests, you work with JSON a lot, and I feel like for now, from what I've learned so far, Python is easier to work with JSON than Go. But I'm not very experienced with Go, so I'm still learning. But so far, Python is easier.
Did you notice any of the you mentioned speed differences between Go and Python? Did you notice any of that in your product, or was it too small to?
Yeah, my project was too small to notice any differences. But from different sources that I looked online, for large applications, Go is very fast compared to Python.
Cool. It'd be faster if you use Rust.
I mean, we could look into microservices with Rust. I'll be down to that.
Now go to that.
Okay.
Alright, thank you.
Yep.
Alright, so that